Hello, CS112. This is a quick solution to Lab 4, which has to do with while loops. You needed to create two functions. I'm just going to be doing part two. The first function, you were going to be given a number, and you needed to determine if that number was divisible by 3 or not. And for the second function, you were going to be given a number, and you needed to determine if the range from 1 to that number was divisible by 3. So kind of count the elements that were divisible by 3. So for instance, in this case, if num was 7, you would need to find the range of 1, 2, 3, 4, 5, 6, and 7 inclusively, and then check for each of these and count how many of these digits are divisible by 3. And in this case, you have 3 and you have 6, which are divisible by 3. So if num was 7, this should return 2, since there are 2 numbers divisible by 3. All right, so we're just going to power through this. I'm going to be calling this function within this function because that's kind of what we expected you guys to do. So now for this one, you're just going to be given a plain old number. You don't have to find any range or anything like that. You just have to determine if that is divisible by 3 or not. And how are we going to do that? Our friendly neighborhood modulus operator. So if num modulus 3 is equal to 0, we're going to return true. And then here I'm just going to say return false. So if you ever want to determine if any number is divisible by anything, you want to check if that number modulus whatever is divisible by is equal to 0. So let's say you wanted to check if num was divisible by 7, you'd make this a 7, 12, you'd make this a 12, so on and so forth. The reason I don't really need an else block here is because this line of code will never be returned if it is divisible by 3, because as soon as it's divisible by 3, the function will return true and it will be over. So if this is false, then it will just go here and return false. So I could add an else block, but there's not really much of a reason to. So let's test this out. How do we test our code locally? Well, we want to print out the return value of this function. I'm just going to copy and paste it, given a number. So let's give ourselves 3 test cases. Let's try with 3, because we know 3 should be divisible by 3. Let's try 33, and then let's try 31. So we should have printed out to our terminal true, if I can type, and false. So 2 things real quick. It's very important that you actually print out the return value here. If you just call the function, it will go through and do the work, but then nothing's going to be displayed to terminal. You actually need to print out that return value. And 2 is you need to call the function after it's defined. So like if I had these function calls above line 1, then it won't realize that this has been defined yet. It'll say the function is not defined. So anyways, moving on here, I've saved the file. I'm just going to now run it. So pi cat.py. And we have an error, which is fine. We can debug it together. On line 11. Oh, so you can't have just an empty function here, so I'm just going to return 3 just for fun. And then if I run this now, we get true, true, and false, which were the expected outputs. I'm just going to comment these out now so we won't see it anymore when I run it. So now we kind of need to implement this on a range of numbers. So how am I going to do that? So I'm going to need to iterate somehow from 1 all the way up to num, and then count how many times a number is divisible by 3 in that range of numbers. So right off the bat, I know I'm going to need a counter variable, obviously, to keep track of how many are divisible by 3. I'm going to set that equal to 0, because so far we have seen 0 divisible by 3. Next, we're going to need to start at 1. So I'm actually just going to call this my guard, set that equal to 1, and then this is where we're going to start our while loop and compare it to num while constantly incrementing it so we can continuously move. So in that range example I told you before, where num equals 7, we're going to iterate through the range of 1, 2, 3, 4, 5, 6, and 7, and that's what our guard is going to be. So in our while loop, it's going to start at 1. So while guard is less than or equal to num, we're going to iterate, and in every single iteration, we're going to increment guard. So during the first iteration, guard would be 1, then 2, so on and so forth. So while I say while guard is less than or equal to num, we want to say equal to because it is inclusive. We want to check that as well. I'm just going to say in here if, and then I'm going to call this function. So is div by 3. And then what am I going to pass in here? I'm going to pass in guard, because guard is going to represent each of these digits. So is div by 3 guard. And that's all I need to say, right? Because this is going to simply boil down to either true or false. So it's going to be either if true or if false, depending on what this function returns. And if it is true, that means it's divisible by 3, meaning that we can just say count plus equals 1. We're incrementing our counts. And outside of here, now there was a very common problem I saw in these labs. It was that people were saying else they would increment guard. And this is going to be an infinite loop. And why this is an infinite loop? Well, what happens if we get down to, like, let's say we're testing 7, it's 1, it's going to increment guard, it's 2, it's going to increment guard, but then as soon as it's 3, it's going to say count plus equals 1, and then its guard is still going to be 3. So it's just going to infinitely loop because 3 is always going to be less than or equal to 7, and count's just going to infinitely grow as well. So you always want to increment guard. So typically in your while loops, you want to make sure your whatever variable you're using as your guard, I call it, it needs to be outside of a conditional because it always needs to happen. So this right here is the solution outside of me actually needing to return the answer. So I'm going to return the counts at the very end. So now let's just call it with 7. So I'm going to now print out the return value of this function call with 7. And I'm going to save that. I'm going to run it. And as you can see, we got 2 because there are 2 numbers within this range that are divisible by 3. Now, if we go to 9, we should get 3 returns because of 3, 6, and 9. And we do. So yeah, that is the solution to lab 4. So if you guys have any questions, feel free to let us know.